Welcome to Artificial Intelligence with TensorFlow. Today we'll be going over the course outline, course expectations, and the recommended setup. A little bit about me. My name is Brandon McKinsey, and I'm currently a natural language processing engineer at Forge AI, a startup located in Cambridge, Massachusetts. At Forge, we implement state-of-the-art models at scale, with low latency inference being a key requirement. That means I'm either reading papers to determine the best model for some given task, implementing that model in TensorFlow's Python or C++ API, or optimizing the model for speed before sending it off to production. A little bit on my background, I studied physics and computer science with a focus on artificial intelligence and machine learning at UC Berkeley. Most of my research background is computational particle physics for institutions like the Large Hadron Collider and the Relativistic Heavy Ion Collider. I started using TensorFlow just a couple months after its first release in early 2016 for a project I had in an artificial intelligence class taught by Professors Peter Abil and Anka Dragan at UC Berkeley. But time for the course overview. The goal of this course is to provide a broad overview of the TensorFlow landscape in order to give you a clear idea of what can be done with TensorFlow. The first section is all fundamentals, a general overview of machine learning, tensors, graphs, sessions, saving models, loading models, all that stuff. We'll then journey on to building our first models in section 2 on computer vision. Along the way, we'll learn about cool topics like convolutional neural networks, max pooling, batch normalization, and how we can train our models on the CFAR10 image dataset. Next, in section 3, we'll look at applications for natural language processing, my personal favorite. We'll learn about the key components found in nearly all neural networks that process text, such as embedding layers and recurrent neural networks. We'll also work through training a neural network to classify news articles from the 20 news group dataset. Then in section 4 on tips and tricks, we'll explore various useful TensorFlow tools for improving and evaluating our models. There's a lot more to the TensorFlow experience than implementing a neural network. We have access to great tools like TensorBoard, training hooks, estimators, TensorFlow debugger, all these things that allow us to visualize and customize the training experience and to do so with very little code. In section 5, TensorFlow in production, we'll see how the TensorFlow experience can be a bit different in a production setting compared to a research setting. In production, we are more concerned with things like speed, which the C++ API can help us with, or serving our models for others to use, which TensorFlow serving can help us with. We also might want our models to be on a different type of machine altogether, like mobile devices, which TensorFlow Lite can help with. Finally, we'll wrap up the course by going over some miscellaneous topics that are interesting in their own right, and popular with many people in the TensorFlow community. From Google's specialized tensor processing units, TPUs, to ideas behind automated machine learning, or AutoML, to the brand new TensorFlow Eager execution mode. There's still so much we won't get a chance to cover, but hopefully the course will expose you to enough resources from different places that you'll have a solid idea of what the TensorFlow community is all about, and where you can go to learn more about your favorite topics. Now that we've gone over what topics you can expect to learn about, we should clarify what we expect the target audience to know before starting. We assume you're comfortable programming in Python. Next, we assume a certain amount of familiarity with machine learning concepts in general. I'll describe in detail what the expectations are in the next video, but the more you know, the better. Since this course covers a lot of different topics, I'll still introduce ideas behind things like convolutional neural networks before we try implementing one, but it's always nice if you've been exposed to the material beforehand. If not, all that means is that you should be particularly focused on reading the additional resources that we give at the end of each video to ensure that you fully understand the material presented. This is closely tied to the last requirement, that you are comfortable filling in your knowledge gaps as a self-study. This course is fully hands-on. We expect you to run every mini project we work through on your machine and play with it so that you can learn more. Next are some recommended topics for doing well in the course, but not strictly required. First, of course, having any prior experience with TensorFlow is going to be really helpful. This course covers a huge amount of material in a rather condensed fashion, and all that means is that you'll have to take your time more in the beginning sections if everything is brand new, because TensorFlow is a massive library and getting used to all of its quirks and conventions can take some time. Also, any familiarity with NumPy will probably come in handy, but that's just a good Python library to know in general. TensorFlow objects share many similarities to NumPy arrays, and you can even convert between TensorFlow tensors and NumPy arrays directly in many cases. Also, the last one is completely optional, but 2 of the videos in section 5, TensorFlow in production section, are all in C++. If you don't know C++, then I'd suggest skipping those videos since they won't make any sense and they don't depend on any other videos in the course, so you don't have to worry about skipping them. One last thing before we dive straight into the course, let's get set up. The main thing is just going to be installing TensorFlow, and I provided a link in the additional resources slide to TensorFlow's installation guides, which are very detailed and very helpful with getting you set up. These are what I'd personally recommend to use as your operating system if you are able to choose. TensorFlow is definitely easiest to work with on Linux and is officially supported for Ubuntu 16.04. With that said, the next best choice is definitely running it on a Mac, something I admittedly know nothing about. Macs have the benefit of being built on Unix, and so you get a similar experience as Ubuntu, but there are Mac-specific installation steps that you'll need to read. But those are all on the TensorFlow installation page. And finally, although you can run TensorFlow on Windows, it's still a rather awkward experience if you ask me. Perhaps by the time you're watching this, TensorFlow has fixed all the kinks, but you're just going to have to search through Stack Overflow posts more than you'd have to otherwise when some Windows-specific issue happens while you're working with TensorFlow. It's definitely doable, so don't worry if all you have is a Windows machine, but just be ready to face the occasional strange error. Next, the course will be using Python version 3.5. I personally love PyCharm for an IDE. It's an awesome Python IDE and makes working with large Python projects a breeze. Many other users prefer using simpler editors like Sublime Text or Vim, just to name a couple. The editor or IDE you choose is entirely preference and up to you. Last but not least, this course was made during TensorFlow versions 1.4 to 1.7. Unless explicitly stated loud and clear, all code in this course will run on any version between 1.4 and 1.7 inclusive, and ideally for any future version 1 releases, since TensorFlow's API stability promise says that minor releases will not break public APIs. The two main ways of installing TensorFlow, both of which are described in great detail on TensorFlow's installation guide, are via either a pip install or installing from sources. I prefer installing from sources because I can build it with all the optimizations my machine and GPU supports, but feel free to install with pip if you prefer that method. Okay, so like I said, in the last slide of every video, there's going to be this additional resources slide like this. It provides links to learn more about the topics discussed in the video. Today, we talked about things like getting set up, so I provided links to the TensorFlow installation guide and to the PyCharm download page. Also, all the code in this course is located at the course's GitHub repository. The code there will have much more comments than the code we see in the videos, like I said. So again, if you're confused about some code that we go over in a video, make sure to check it out on GitHub to see if I've included comments that answer your question. If you still have a question, post an issue on the GitHub repository and I will do my best to get back to you and include more comments on that portion of code.